So the self-describing wishbone bus, one of the projects with the worst acronym yet. A little bit about myself. I'm an Indian, studying in Spain, working in Switzerland at CERN, living in France. I work in the hardware and timing section at CERN, where we mostly develop timing and data acquisition hardware for accelerators. And one interesting thing we do is we upload all our designs and software up on the open hardware repository, which allows us to collaborate with a lot of other institutes across the world. Most of our hardware is VME and PCI, which is currently being upgraded to FPGA-based designs. What's that? Oh, it's an ancient bus standard, which is mostly used in high data rate acquisition systems. So I personally work on Linux device drivers. So a little bit about FPGAs for the uninitiated, which I think is no one. They're gate arrays which can be programmed in the field, made up of logic blocks, and you describe the logic in an HDL, which is then synthesized and loaded onto the FPGA. And what you get at the end is dynamic hardware logic, which is a really cool thing to work with. And these are two of the FPGA-based hardware we have at CERN. The first one there is the Spec Board, a simple PCI Express carrier board. It's a modular piece of hardware with an FPGA there, and you can plug in a different module and reprogram the FPGA for custom applications. The second one is the White Rabbit switch, which is Ethernet-based switch, which allows you to synchronize up to 2,000 nodes across 10 kilometers down to sub-nanosecond levels. What they both have in common is they make use of the wishbone bus as an interconnect inside the FPGA, which is an open community-developed bus protocol, which is being developed by the guys at the Open Cores website. Some of them are in the audience, which is really great for connecting logic blocks. So we use them. And you basically place them into, an integrator takes these blocks, connects them together, and what you get is a single wishbone memory map, and you can map and access this as usual. For example, in the Spec Board, we do it on the PCI memory, and then you map that onto the PC memory. When you're trying to write drivers for such designs, you could write a monolithic driver, for example. You could have one driver for every combination of hardware and FPGA design. And I'm talking about modular hardware, like in the case of the Spec Board. But when you do this, you get a really vast problem space, and it's not very practical. So one thing to remember is that you're reusing the blocks in different designs, and it would be really cool if we can exploit that when developing drivers. So ideally, you would write a single driver for a single wishbone-compatible logic block. And to do this cleanly, you need to have some sort of auto-discovery. And currently, it's not defined in the wishbone specification. So let's just add our own. So you want to discover a bus which has devices connected on it. How would you go about it? You need device identification. You need some way to know what device it is you're talking to. You need, if possible, firmware metadata. And a support for device hierarchy. For example, if a router block is controlling multiple Ethernet blocks, you want to be able to express that relationship in this specification. And you don't want to leave proprietary blocks out in the cold because it's bad for adoption. And we really want this to be adopted as a standard if possible. And two things to remember about proprietary blocks is that they cannot be modified and can contain an entire device hierarchy within them. We don't want to constrain designers, and we don't want to use external metadata if possible, because it's really hard to keep track of them, and they go out of date really fast. So how do you actually go about doing this with our specification in the current form? Let me just say that it's quite fluid at the moment, and we're still looking for comments on modifying it. So each device gets a vendor and device ID. We've gone with 64-bit vendor IDs to prevent scarcity. You have some other stuff as well. For firmware metadata, we have a separate ID block containing information about the firmware. And you add another header block which actually points to both the ID block and the list of devices. And now all you need is the location to this header block, and you can discover the entire bus. For supporting hierarchy, one way to do it is to have children saying giving every device a number, and you have a child saying my parent is device number A. And this is bad because it's a one-to-n relationship between parents and children, and a modification in the parent causes n changes in the children. So instead, we have parents having a variable list of child locations, and that way modification of the parent doesn't require modifying the children at all. To support proprietary blocks, we make use of relative offsets so that you can basically place an entire hierarchy anywhere in the map, and it works without any problems. And now all you need is an array of top-level devices. That's the top root node of all the tree hierarchies. And you put that location somewhere in the header, and you're done. So for example, if that's the wishbone memory map, you take a header. It points to the ID block. You have a pointer to a bunch of top-level blocks. And each of these provides the offsets into device descriptors, which can be placed inside the device blocks themselves. For example, if one of them has children, then it can again provide offsets into the children blocks themselves. And one thing to remember is that device 1 and device 2 here and child 1 and child 2 there are the same structure. So it's a sort of recursive design. And even if you have an entire hierarchy which is behind a proprietary blob, you can still support it because it's all relative offsets. So you take the header location and give it to the FPGA hardware driver. And this, you also load the wishbone bus driver and a set of drivers for every single block in the FPGA. And all you have to do is register wishbone bus. And you provide some operations for reading and writing to this memory map. And you provide the location of the header. This basically goes through the specification we've designed to extract the hierarchy and device information. And it calls the probes for each specific device. And it passes it the entire device hierarchy for that specific device. So the driver can decide what to do with the child nodes. Some test drivers I've written are very basic ones at the moment. One wire I2C block driver, which is connected to an EEPROM, I think. In February, I'll be working on an ADC controller, which is more complex, and testing out the specification. So in the coming few months, I'll be working, like I said, with a little more complex hardware. We want to integrate with the Wishbone standard if possible, and some people from open cores have shown interest. So I think that's in the near future somewhere, but we still need to work on the specification a little bit more. We'd like to go upstream. Currently, there is no bus driver for Wishbone in the Linux kernel. So that's the first thing, but we have to provide support for older kernels because CERN uses ancient ones. I think we use 2.6.21, which was a few years ago. And we'd like to have some drivers ready to go by the time we push upstream. So that's just a really short introduction to the project. Hope that was informational. That's the Open Hardware Repository website for this specific project. So take a look. Any questions?
Yeah, can I ask why you went with a sort of custom discovery system and block specifications instead of, say, taking the existing device tree?
Right. Well, we did look at device tree, but I think it's more geared towards static structures and when you're running Linux in the FPGA itself. So, and we didn't want to have external metadata, so we stayed away from device tree. And if we are planning to have device tree inside the FPGA itself, in maybe a ROM block, then it's not very space efficient, so we didn't go with that.
Yeah, it uses strings, right? So
right, exactly. Any more questions? Oh, okay, yes, go ahead.
Yeah, I tried to download the PDF of your spec earlier today, and the link is broken. It came up with error 406.
Okay, I think it's there in the repository. Maybe I'll check it today afterwards. No, definitely. Yeah, yeah. Thanks a lot. Yeah, yeah. This would work with any device discovery, in fact. Uh-huh. Right, right. We were actually discussing that yesterday I was discussing with Alessandro, and we think it'll be useful for general auto discovery in any sort of situation, not specifically for Wishbone. So, any more? Okay, so thank you.